In the normalization process, we have seen first normal form, second normal form, third normal form, and BCNF, that is Bicot normal form. So let's revise our all four normal form one by one. So what first normal form says us? The first normal form says that every field should have atomic value. Every field should have atomic value, right? What second normal form says that? Second normal form says that your relation should be in a first normal form, as well as there is no partial functional dependency. It is in first normal form plus no partial functional dependency. Okay. Then we have the third normal form. Third normal form says that it should be in a first normal form as well as in the second normal form plus no no transitivity rule, no transitivity rule get the functional dependency, and that functional dependency should not be in a form of key determine some non-key. This should not be there with the transitive rule. Then we have BCNF, which is called Bicot normal form. It says that it should be in a first normal form, it should be in a second normal form, as well as your table should be in a third normal form, means your table should be normalized up to third normal form plus the determinant part should be the candidate key. Your determinant part should be the candidate key. It means that if we have a function dependency like this, then this should be the key all the time. The left hand side, the determinant part should be the key in your all function dependency. This is BCNF, which is called Bicot normal form. So let's see with one example that how we can solve all those functional dependency. So in your examination, it may be asked with one example, one question may be asked, and it will be asked to normalize it up to BCNF. Getting it? Normalize the table up to Bicot normal form. In that way, you may get question. So let's see one example in which we have a relation R. R is having attribute A, B, C, D, E, F. So how many attributes are there? 6 attributes are there in this particular example. Now the functional dependency that is given here is AB determines C, C determine DE, A determines F and F determines A. Okay. Now the question is normalize the table or normalize the relation R up to BCNF, Picot normal form. This is your question. So how you are going to solve it, or how you will find out a table up to Picot normal form, right? So this is our question. Let's try to solve this. Now, how you are going to solve it? For solving this type of question, we have to go for the first normal form. See, we doesn't have the table given, so we don't know that how many values are there in one table. So we assume that if these are the question, these type are the question, so it is in first NF. So it is already in the first NF. Now go for the second NF. What second NF says? Second NF says that your table should be in a first NF and no partial functional dependency will be there. So we find out that because the table and the data is not given, so we assume that it is in the first normal form, means every value which we put into the data is atomic because value is not given. Now, second normal form says that it should be in a first normal form. So yeah, it is in the first normal form. No partial functional dependency will be there. So to finding the partial functional dependency, what we have to do? What we have to do? To finding the partial functional dependency, we have to find out the key. What is the key? So to finding out the key, let's go for the closure process. So at very first step should be find the closure of all the determinant to get the candidate key. So the first step is to find out the closure. So what is a closure here of determinant? Let's go for AB plus AB closure. AB closure is nothing but AB. AB is determining C. C is determining DE. And E is determining F. A, B, C, D, E, F, which is equal to R. It means that R is or AB is candidate key. Okay, candidate key. Now let's go for C closure. C closure, you'll get C. C is determining DE, you'll get D and E. E is determining F, you'll get F here. F is determining A, you'll get A here. Anything else? No. Which is not equal to R. Why? Because B is not here. Now let's go for E closure. What is E closure? E closure will be E. E is finding anything? Yes. E is finding B. Sorry, F. F is finding A. That's all. Which is again not equal to R. Find out F closure. F closure will be F. F is finding A. I think that's all. Which is again not equal to R. Right? So what is the candidate key here? So the candidate key we have is AB together, right? And it is also the primary key because we have only one candidate key. So we have that candidate key will become the primary key. Now, after considering AB as the primary key, can we say that do we have any partial functional dependency? It means that alone A is determining anything or alone B is determining anything here. Now, if you'll get it or if you'll see that, so you'll find out like there is no partial functional dependency because AB together is finding something and A alone or B alone is not at all finding anything. It means that it is in second normal form. So we can say that because there is no partial functional dependency exists, hence R is in second normal form. Okay, so your R is in second normal form because there is no partial functional dependency exists. Now let's go for the third normal form. Now what third normal form says that it should be in a first normal form and second normal form. So here we have just proved that it is in second normal form because there is no partial function dependency if AB is the key. No transitive rule get the functional dependency key determine the non-key. So do we have any uh, transitivity rule if we'll apply here? Do we get anything like that? So if you'll see AB determines C and C determine DE. With that, can we say AB determine DE? Can we say that with the transitivity rule? So yes, we can say that. And here if you'll see, this is the key and this is the non-key. So we are finding the functional dependency with the transitivity rule. We find out the functional dependency with the transitivity rule where the determinant part is the key and the non-determinant part is the non-key. We are getting it. So because of which particular functional dependency we are getting this. So because of this functional dependency, we are getting this, which is a problem with the third normal form. Any other transitivity rule, if we'll apply the transitivity rule, do we get any other? We'll see here, E determine F, F determine A. What will get? E determine A. With this rule, which is E determine F, F determine A, we are getting E determines A. But here you see this is non-key and this is the part of the key. So in this case, it is not violating the third normal form. Why? Because it is not in the form of key is determining non-key. Here it is non-key is determining part of the key. So it is not bothering the third normal form. So this is not creating any problem. Only this is creating the problem. So you have R. R should be split into R1 and R2. In the R2, we'll put those attribute or those dependency which is creating problem. This was creating problem. We are putting in one. Let's put the rest of the thing here, which is A, B, and then what we'll put? E is already here. A, B, C, and F. Getting it? So here we are getting A, B, C, and F. Here we are getting C, D, E. So what are the functional dependency that is there, which is A, B determines C, and what about F? E determine F is not here. Okay, here it should be E determine F also. So E will also come here. So we may have two attribute here. Okay, that will be a problem. So this is one functional dependency that is there. Rest of the functional dependency will be dissolved. Here only one functional dependency is there. Now if you'll see these two relation, which is R1 and R2, you will get to know that here AB is the key, because AB closure you will get, okay, AB, you need F actually somewhere to find out the value of F, right? So here E will also come somehow. So E determine F, this functional dependency should be there. E determine F, this functional dependency will be there, and F determine A, this functional dependency will be there, which is this and this. This functional dependency is going to another table. So all three functional dependencies here, and this is here, right? Now, what is the key? Key here is again AB, because AB closure, what you will get? You will get A and B. AB is determining C. Then what about E and F? You are not getting E and F. F. So what should be the key here? We are in the third normal form right now. So if we have, I think we have to go for the transitivity rule. So AB determines C, AF determine FA, E determine A. Okay, okay, okay. If we are going to remove E, then we have this functional dependency here. AB determines C, F determine A will be here. So my key will be A, B, and F. because here A is missing, right? F is missing. So if I'll have B, F closure, what I'll get? I'll get B and F. From F, I'll get A. From A and B, I'll get C. So if I'll do like this, I will have the new key here, which is B and F, which is B and F. Okay. Hmm. Right. Now, if you'll get the third normal form, you doesn't have to check for the functional dependency again because this is a separate table and this is the separate table. Now, let's go for the BCNF. Now, here can we say that R1? So we can say that R1 and R2 are in third normal form. Okay, R1 and R2 are in third normal. Now, let's go for BCNF, which is called boycott normal form. Now, to finding out boycott normal form, all the determinant should be the candidate key. So for R2, there is no problem because in R2, we'll find C closure and in C closure is C, D, and E, which is equal to R2. And here C is the candidate key as well as it is a primary. So it is the determinant part. So R2 is in BCNF. There is no doubt in that. Now for R2 is in BCNF or not, we have to find out the candidate key. So what is the candidate key that we have find out here is, can we say AB is the candidate key? No, because AB will find A, B, and C only. Can I say B and F are the candidate key? If you find out B, F closure, then only you will get B, F. F is finding A, B is finding C. And that way you can say that this is the candidate key. This is the primary key also. Now to take this as the candidate key, here we have AB determines C. So here AB determines C is not the candidate key. Here F determines A. So F alone is not a candidate key. Now for that, what we have to do is this R1 should be split into two tables, R3 and R4. In R3, we have some amount of, and R4 we have another. So here, let's say we are putting A, B, and C, and here we'll put A and F. Now A, B, and C. So here we have the functional dependency A, B determines C, and here we have F determines A. Now for this, what is the candidate key here? The candidate key here, it will be F closure, which is F and A, which is equal to R4, which is the candidate key as well as which is the primary key. So because F is the candidate key and the primary key for R4, so this is in BCNF. In this AB closure, we may get A, B, C, which is equal to R3, which is nothing but the candidate key and which is the primary key also. So here AB is the candidate key or the primary key. So here R3 is also in BCNF. So we can say that R3 and R4 is in BCNF or Bicot normal form. Getting it? So this is the way how we can get up to the normalize the table up to BCNF. So how many table we have with R? So R has been divided into three different table, which is we have R2, we have R3, and we have R4. In R2, we have C determine D, E. So we have C, D, and E. In R3, we have A, B determines C. So we have A, B, and C. And in R4, we have F determine A. So we have FA or AF, whatever you want. So this is one table, this is another table, and this is another table, which we get from the relation where we have the table BC, D, E, and F. This is the table. It is divided into three different tables and it is normalized. This is normalized, this is normalized, this is normalized up to bicot normal, right? So this is how you will do the normalization process, and this is the procedure to do that. So all the time you have to find out the candidate key for each table. As we have find out the candidate key for this table R, then we have find out the candidate key for this table, which is R1. Then we find out the candidate key for this table R2. And then we find out the candidate key for this table R3 and this table R4. So for all the table that you will split, you need to find out the candidate key or the primary.